Good afternoon, everybody. So, in this last lecture of gradually varied flow, we discuss the method to find out the length of surface profile. This is the topic which is very important from the examination point of view, also, where you need to explain the procedure and also to solve a problem based on the procedure. So, we will do the same in this lecture. Both we will take up first the process to find out the length of the surface profile in case of a gradually varied flow, and then do a problem relate, related to that. So I will take you straight away to the whiteboard. So the topic which we are dealing now is the length of the surface profile in gradually varied flow. This is our topic. Normally, in practice, it is often required it is often required to determine the distance up to which the surface profile of gradually varied flow extends. For example, if a weir is constructed if a weir is constructed across a river, having mild slope, just take as an example, then it is required to estimate the distance up to which basically it is required to estimate the distance up to which the water surface profile is affected by the construction of weir. This is what we have to do it. So if you want to solve, in order to solve this problem, basically, the only thing is integration of gradually varied flow equation is necessary. That is the only way. Whatever gradually varied flow equation is there, that we have to integrate that equation, basically. There are various methods for integrating GVF equation or the step method, which we generally use. The second method is basically graphical integration method. And third one is direct integration method. But we will follow this method actually here. The method which we follow is the step method. What we will do in the step method, for example, suppose this is the channel bed. Its slope is S naught. So this is a horizontal. It is a horizontal datum, right? Then this is the water surface. Then this is the energy line slope SF. So if I draw S, this is the thing. If this I take it as dx, the length, and this is y1, this is y2, this is v1 squared by 2g, v2 squared by 2g. So naturally, why this loss is there, energy loss? This we call it as HF, right? Now if I take it, channel bed slope is S naught, energy line slope SF, that's general, right? What we will do in this method is, in this method, the entire length of the channel is divided into short lengths and the calculation is carried out step by step from one end of the channel to the other end. We divide the entire channel reach into number of sections, and we try to find out each length of the section. So such section it is 1 and this is 2, which we divided, and now that length is dx. So now I find dx. Similarly, the same method I used for the next section, next section, next section, like that till the entire reach is covered. We go on do repeating this process actually. That is what this method is. But how to do that? Now I will equating the total energy at both the sections. Section 1, S0 into dx. What is this? This is S0 into dx plus y1 plus v1 squared by 2g is equal to, here 0, this is only y2 plus v2 squared by 2g plus hf. So S0 dx plus y1 plus v1 squared by 2g is equal to y2 plus v2 squared by 2g plus, this hf is nothing but sf into dx. sf into dx. So if I see it actually, so this s0 into dx plus, what is y1 plus v1 squared by 2g, already we have studied specific energy E1. Similarly, this if I take it, this part, then E2, this is plus sf into dx. So if I take that also on this side, S0 minus SF into dx is equal to E2 minus E1, or dx is equal to E2 minus E1 divided by S0 minus SF. So this is the equation which we use to determine dx. This is the equation we use. Now, what is the process? How I do the process? Let us take the process. Please listen carefully. The procedure. I will explain you step by step. First, the objective is to calculate the length of surface profile, which we call it as, for example, x. Now, data which should be data to be given. Number one, discharge should be given, bed slope should be given, channel shape should be given. Then only we can calculate area or not. Whether Cheji's C or Manning's N should be given. And last, depth of flow. One depth of flow. So Q, S naught, shape, CRN, depth of flow. So these are the two things to the given. Now what we will do? How to start the process? Calculate area, perimeter, hydraulic radius, right? Hydraulic radius corresponding to known depth of flow, y1, right? So yeah, normally rectangular only given. So therefore area is b into y1, perimeter b plus 2 y1, r is equal to a by p. That's all what you will do. Then actually knowing that, the next one is here itself, calculate velocity, velocity head, and specific energy at this section, right? These are the three. Then knowing this, actually what you can calculate, use Cheji or Manning depending upon coefficient given, find SF1. This is the first thing. So at the given point, given section, at the known section, find out these three steps. First step, A, P, R. Then v squared by 2g, e1 is nothing but actually y1 plus v1 squared by 2g. That is what you should understand. Then next, after this, substitute in that and get this SF1. How to get SF1 if you have a doubt? You take V is equal to C root R SF1, right? Then in that case, V square is equal to C square into R into SF1. Therefore, SF1 is equal to V square by C square, or this you can do it at known section. Or if you want to use P is equal to 1 by N or 2 by SF1 to the power of half. Same, again square both sides. V square is equal to 1 by N square into R to the power of 4 by 3 into SF1. Therefore, SF1 is equal to V square into N square divided by R to the power of 4 by 3. Either use any of these equations and find out what is SF1 at section 1. This is over. So 3, 4, 5 are you are carrying out. Then what you do it is next. Assume a new depth of flow, a new depth of flow y2 close to the known depth y1. So yet this new section, find A, E, R. Yet this new section, find V, V squared by 2G, E2. Then after finding out that, find then SF2 is equal to V square by C square or V square N square by R to the power of 3. So over. Then next step is what is average SF? It is equal to SF1 SF2 by 2. Find out this SF bar. Then next step, use the equation dx is equal to E2 minus E1 divided by E2 minus E1 divided by basically S0 minus SF bar. Use this, find dx. So this is all basically at the second section. This is final. Then what you do? Then actually after that, repeat the same process till the total length is covered. Total length of surface profile is equal to dx1 plus dx2 plus dx3 plus so on. The same I will show you through a problem based. how really we can solve this type of problems that I will take you and then take very, very interesting thing because in the exam, this is one possibility in this particular thing.
Like, share, and subscribe. Hit the bell icon for more updates.